Hello, I'm Scott. Thank you for hosting us, Grid Dynamics, and Microsoft as well. I am here to change gears again to being on the cloud and with a lot of more kind of like data engineering type stuff. But today I'll be talking some about attribution modeling, how we get set up with that, how do we deploy it, maybe some interesting insights and observations along the way. So quick agenda. I'll give you a brief introduction into what attribution modeling is. Show of hands, have many people heard of attribution modeling or know what it is roughly? Okay, good. Lots of opportunity for learning tonight then. Excellent. So first we'll talk about that. We'll talk kind of like the end-to-end modeling approach in broad brush strokes. How do we handle big data in the cloud? In this case, we'll be looking at Google BigQuery. We'll do a little bit of stuff in R, and we'll see how we can take that data and see it in some sort of visualization layer like Tableau or Power BI. So a little bit about me first. Hi, I'm Scott. I think I already said it. My background comes from the world of academia, physics and astrophysics. I did my undergrad up at Western, a little bit north of here. Did my graduate studies abroad out in England for astrophysics, which led me into data science. It's where all the astrophysicists are going these days. And worked for a little bit, actually, right across the street in 2018 for the Visual Studio Team Services team at Microsoft. Most recently at Tableau, and done some fun hobby things like writing a book on Intro to Machine Learning with R. You can find it on Amazon or the O'Reilly website. And this fantastic photo of me, courtesy of Ted Wolf Photography, is me at the Redmond Derby Days Criterium bike racing downtown. It's a great experience. If you can go there, be sure to check it out. They have lots of other stuff to do other than bike racing. All the slides tonight will be available on my blog at svburger.com. So if you don't want to take photos off your phone and can't read them later, just feel free to go to the site. They're already posted. So, attribution, learning time. The goal of attribution modeling in a nutshell is to make sure that we are spreading out our marketing budget effectively. So what does that mean? Well, in a lot of cases, what you can have is if you have users that are doing some sort of interaction and they are converting in your customer funnel to the very top layer of lead status or something like that, some sort of conversion activity. Sometimes people will look at something that's called a last touch scenario. So whatever the last thing that someone interacted with, that's what gets all the credit. And this is very easy to implement. It kind of makes sense to some degree, like, oh, well, someone came to our download page and they downloaded a free trial of our software and converted to a lead that way. So let's just give all the credit to that trial download page. Kind of makes sense, but at the same time, we're losing out on a lot of fidelity for steps before that. Maybe they saw a really cool YouTube video. Maybe they saw a really good white paper or something that really piqued their interest more and really drove engagement a lot more than just the last interaction that they had. So that's kind of the overall motivation for what attribution is. We're making sure that everything gets as much credit as it can. So this is an example of the difference between a last touch and a multi-touch attribution. So last touch, so let's say like an example, someone comes to our company's website. They come in through some sort of marketing channel, let's say like an email or something, and then they click around a bit. Maybe they go from one page to another page, first touch to second touch. They leave, they come back on a new session, different marketing channel. Maybe this time it's direct traffic because they already know about the site and the product and everything, great. And then they convert. Last touch is going to say, well, they converted on this trial download page. Let's give all 100% of our budget to those guys. The trial download people are ecstatic about that. Great, we get 100% of the budget. When in reality, the actual user journey is much more flipped towards the majority of the channel that they've been interacting with. So this helps us make sure that everyone gets the appropriate credit that they deserve, and what we'll be seeing tonight are various methods that we can go about building the foundation for that. So the modeling process overview, we start with developing user journeys, so seeing the whole landscape of what people can possibly interact with. We do this with Google Analytics data in our talk tonight, and that data being hosted in Google BigQuery. So we'll get a lay of the landscape there. Once we have those user journeys, what we do is we can tie conversion rates to them. We can see which journeys are better at converting users than others. And then once we have that path data associated with it, then we can put it into some sort of more meaningful statistical model. In this case, we're using a Markov chain model. We'll dive into that in a little bit, to help make that a more robust and statistical process instead of something that's just like the last thing that they interacted with. So for that, we use R. And then once we have that data, we punt that back up into the cloud. You can also do that locally, but in our case, we'll be pushing it back up and then pulling data from that down into some sort of visualization layer. So Google BigQuery. The cloud is good for some things, not so good for other things. But in particular, Google BigQuery worked for our implementation because it really acts very well in two ways. One is handling huge amounts of data. So we're talking, well, huge in relative terms, but for Tableau, huge means about 250,000 rows a day. And if we want to look at a whole year's worth of data for one kind of model and then seeing it year over year, that gets really big very fast. And one advantage that we have in Google BigQuery is that we can take all of the raw, fine, granular Google Analytics data that we have and just dump it natively right into Google BigQuery. GBQ has some extra bells and whistles on it that we'll see in a little bit. But one thing that you can see just from this standard view, if you just go to cloud or console.cloud.google.com/BigQuery for the new UI, you can play around with some example data sets that are on there, and you'll see some, in this case, one that I've been playing around with from the National Oceanic Atmospheric Administration, NOAA, where we have a bunch of tables of weather data. And this is data per year where each table is its own year, and that just goes on forever. So we'll be seeing a way to handle data like that. There's just tons and tons of tables of data. So the first kind of step in building out our user journeys has to deal with this huge amount of tables of data that we have. So for each one of these tables, you may have zillions of rows associated with them, but maybe we're only interested in a very select subset of these tables. Well, BigQuery has some fun little techniques that you can do. One is called table wildcarding, that if you have a table that has basically the same kind of schema with it, but it has some kind of date formatted string at the end of it, then what you can do with BigQuery is you can say, okay, well, give me data for just one day, and you can query that table just with the suffix for March 6th or something. But let's say, oh, actually, I want all of the data for March. Well, instead of going and putting in your select statement, for dates between this and this, which has a little bit of nuance with how pricey it can get. Instead, you can just say, oh, well, give me everything from 2019-03 star. And what the star will do is it will append all those tables with that kind of prefix to each other. So it's kind of like a big union in a way. You can do that one step further for all of 2019 data, and be warned, if you do that for all of your data, that can get really, really big. So make sure that you have a good understanding of how much data you're playing with first before going about doing this. Likewise, if you want to do kind of like ranges of dates, but want to be more kind of specific to the table schema itself, you can do something where you do, in your where clause for your statement here, you do like a table suffix between some date and some other date with this kind of format. What's fun is that you can actually set dates in the future for which you don't have data yet. And when you run these queries, when the data actually comes in, then it'll just auto-append there. And it won't give you any error, so make sure that you're using it appropriately. But this is a way that you can make sure that you have like an unbounded future window for your data, but still kind of time-bound in a way. Okay, so this is still kind of laying the foundation. But what we've done so far is we've seen that data in BigQuery with Google Analytics can be big. It can be, there can be a lot of different tables. Well, you can have a lot of tables, and each one of those tables can have a lot of data associated with it. With Google Analytics data specifically, how many people here are familiar with like web data or Google Analytics data? Okay, a good number of hands. So I think for the most part, people are relatively familiar with sessions. You come to a site, you click around a bit, maybe you leave. That kind of defines a session. The things that you do within that session are what we define as hits. So if we want to establish a user journey based at the hit level, and not necessarily the session level, we have to take that data and we have to what's called unnest it. So in BigQuery, what you'll see, and there is actually a Google Analytics sample data set up in the BigQuery kind of sandbox that you can play around with. I've been trying to get a screenshot of it for demo purposes here, but it's been down, of course. But once it gets back up, you'll be able to take a lot of data from here and play around with it in the sandbox. So in BigQuery, what you'll see is session data. And this is for each one of those date tables. But you'll see session data, and for each session, you'll see a bunch of hits. And if you're trying to build a user journey, you want to go off hit level instead of session level for various reasons. But the crux of building out the lowest level user journey here is with one of the hard to see lines on this slide deck here where it says unnest hits. And what that will do is it will take that session and it'll break it out row-wise so that each row is its individual hit. But because Google Analytics data contains everything that the user is doing, including scrolling on the page, clicking on things, how long that they're looking at things like that, in this case, we're really only interested in what pages they're looking at, because we want to see where they go from page A to page B, maybe back to page A to page C, that kind of journey. You can extend this to things like what users are interacting with and what they're clicking with. That gets even bigger. So this kind of project has definite ranges of big data that it can span. So once we have user journeys and once we have a data set that looks like an individual user, actually, let me go back one slide here. So just to describe some of the data that we have here, this is data that has been unnested from one person's session, where we have a session timestamp, we have all the individual hit timestamps related to that session, we have someone's unique identifier, and then we have like what kind of sequential page journey that they took before converting to a lead. So this is what this user's journey looks like from a row level perspective. But if we want to do something useful with this for attribution modeling purposes, we need to kind of take this and pivot it out into, here's this user, here's their journey. Here's another user, here's this user's journey. And then look at all those individual journeys themselves. So that's this slide. There's a really useful function in Google BigQuery that does that pivoting for us called stringag. This is really great where we can look over an individual user and aggregate all of the different sites that they're visiting to sequentially, so order by their hit timestamp, and then pivot that out into their unique journey. Then what we can do is we can say, well, for that person's sequential journey, we can say we can group all of those unique journeys together. We can see a lot of different statistics about them, like how many number of touches were in that journey path. So these are all the unique journeys possible in this contrived example. We can see how many of the channels within these journeys were unique or not. In this case, I'm just pulling an example that has all unique channels per. But that's another kind of interesting thing to look at. We have a total number of conversions for these various journey paths. We have total unique visitors for all these things. And then this is the data set that we want to be working with for pushing this into more statistical models into R. This is all, of course, obfuscated data, but if you're doing stuff where you are looking at impressions and seeing how users are seeing ads within their journey, you kind of have to pump the brakes a little bit. You're free to do that, but depending on the different types of ads that you're putting in there, that can also balloon your data up quite substantially. So there's a lot of pitfalls and a lot of high wire balancing acts that you have to go about doing this, but generally speaking, this is the kind of data set that we want to work with for modeling in R. When we do attribution modeling, there's a number of different sort of rule-based or heuristic approaches that we can do, a lot of which are just very easily programmable into SQL logic. So things like last touch, we've seen that. First touch, this is just putting all the credit to the first thing in the user's journey. You can do a first and last, which is just assigning half credit to each of those. Linear, spread it out across all the touch points. Time decay, maybe putting more importance toward the events closer to conversion. Position-based, maybe something more custom. But we were more interested in statistical modeling approaches and seeing how that differed compared to other modeling techniques that we were using. All of these, so this is a screenshot from the Google Analytics UI, which is great to use. I'm a big fan of it. However, if you have senior leadership that's asking, okay, like that's great, you're using a time decay model. How is that working exactly? And I think a number of us have probably encountered Google documentation at some point or another, and it can be very good, and in some cases it can be quite sparse. And in the case for statistical models, it's quite sparse. And what this really drove us was to say, well, we can use this this UI approach in GA to do our attribution modeling, but if we really want to understand how it works down at like the code base level, then we can do this model shaping that we've been looking at the past couple slides, and we can bring in R or other statistical programs or packages and kind of do it ourselves. And then that way we have code ownership. We know exactly how all the code is working down at the lowest levels, and we can tweak as appropriate. Here's a view of what the Google Analytics UI looks like, and it's a little washed out, but on the far left, what you'll see is a drop-down for conversions. If you click there, you'll get an attribution arrow at the very bottom. You click that, model comparison tool. This is where you would land on all these different attribution models. This is another thing that you can play with in the Google Analytics sandbox. So if you're just dying to jump in and just start playing with knobs and dials, by all means. But if you're going through and you're trying to do some analytics with the more statistical models, you may run into some issues of maybe explainability. So what that brings us to is, okay, great, we have our data, we have unique channel paths, we have conversion rates tied to that. What we do then is two things. We leverage a package called Big R Query, which helps with input and output from R in and out of Google BigQuery. So we can take data that we've already seen from GBQ, we can push it down into something like a VM layer on Google Cloud where we're running an instance of R. We have our second package, in this case channel attribution. Single line of code, it's great. Markov underscore model. There's some other kind of tuning parameters that we can throw in there as well, but that gives us an output that we'll see in a second. Here are the number of conversions expected for various channels, for marketing channels like email, direct, your paid channels, that kind of thing. And then once we have that table, we can push that back up into Google BigQuery. We can save this locally too if we want, but we'll see the value of pushing it back up into our data warehouse in a sec. But this pipeline here is really useful because it gives us a lot of flexibility in terms of tuning the data. Maybe we want to look over specific date ranges, account for seasonality, look back windows, that kind of thing. And as well as flexibility in terms of model tuning, like with Markov chain modeling, maybe we want to look at a chain length of 2 or 3 or 4, or things like that, and see how those things vary. It's very highly experimental. So the main output that we get from our channel attribution package in R up here is that for the different marketing channels that we have, maybe we'll have a bunch of different heuristic models, first touch, last touch, linear, those types of things, very rule-based. What we can do is we can join on that data with Markov data. In this case, this is all example data, but you could Markov data could be something like 100.3. It could be more decimal oriented as opposed to just whole numbers. But this top level output here is very useful because it can tell us differences between just pure last touch and other statistical models. You can input like Shapley or other things in here, which is very useful. And then you can see how the distribution of these changes per model selection as well. But one thing that's very nice in terms of value is taking some of these models and looking at their fractional credit per hit and putting that back onto the data warehouse, or the hit level data in the data warehouse. So what this means is, from our output, maybe let's say we have our first 3 channels have an expected lead value of 100, 200, and 300 specifically. So in this example user case, they have 4 hits to the site. They have 4 touches. That's their whole journey before converting. And for the first channel that they interact with, it's channel 1, then channel 2, then maybe back to channel 1, then channel 3. We take each of the expected lead conversion values for each of those channels and just put those in as appropriate. And then what we do is we divide by the sum total to get the fractional. And so what this gives us is, for this example user journey down here, for their 4 touches, we can see their first, their last touch, and the associated credit that we should shift appropriately. So their first touch, boom, gets all the first touch credit. Last touch, boom, gets all the last touch credit. Linear, as expected, gets 25% for each of those 4 hits. And then the Markov model gives us a decimal breakout for each of those touches. And then what we can do is we can just take that data and then push it down into a visualization layer like Tableau. Then what we can do is we can say, well, what's today's attribution? How does that look like compared to like with a month-over-month, year-over-year view, that kind of thing, and then compare all of the subsequent models as well. And this really gives us a lot of flexibility and power to show how the data is working and evolving as fast as we can get it. So just to kind of sum up some high-level findings and summary that we've gotten out of this, that our multi-touch approach with a Markov model specifically showed pretty good results for 2+ journey touches. In this case, we want to look at 2+ because, number one, if you're looking at just single solitary touch points, that falls back into a first, last touch, those things basically being the same. But you also have to worry about things like cookie abandonment. Maybe someone comes to the site on their phone, and then maybe they come 2 days later on their desktop computer, and you have a break in linkage there. So by looking at 2+ journeys, that gives you a little bit more of a substantial data set to play with. And you don't really lose much by doing that either. But what we saw was that credit was shifted away from our direct channels into our paid channels. So this is something that we were looking for. If you have traffic that just comes directly to the site, that can be, and then converts, sometimes that can mask if you have paid channels where you're dumping a lot of money into. What this will do is it will show what kind of shift can you expect from those direct channels to those paid channels. I've kind of talked a little bit about impression overload. If you have impressions from like one kind of major source, we'll say, that's probably fine. But if you start including impressions from, like, let's say you have impressions that people see from Facebook or that people see from LinkedIn. Those are generally, fine to add, but if you start adding more and more different types of impressions, then what that's going to do is just going to fracture out the number of channels that you have, and it's going to shift the channel credit accordingly. So you run the risk of having more and more credit shifted away from various channels that may obfuscate the picture that you're looking for. Another big thing is with Google data, you want to make sure that you are working with viewable and measurable impressions. There's actually some quite good documentation on that one, but that's another aspect where data can change wildly depending on what kind of field that you're looking with. And then lastly, with Markov chain data or Markov chain approaches, we saw some decent improvements with Markov chain length 2 versus 1, but we got diminishing returns after 3, and you run into issues with resources after that as well too. So this is my last slide. These are just kind of links to the things that I've been talking about so far. If you want to go and play around with the GA UI, here's a link to go and do that. If you want to get started with Google BigQuery and start clicking around and playing around with stuff, the example data sets they have in there are quite fun. They have a lot of cryptocurrency data sets in there, which I think are very interesting. Don't know anything about them, but they're quite fun to play with. And so that's the link for that one. If you want more info on how to use the R package channel attribution specifically, there's a link there. And of course, you can find all this stuff at my blog, sbburger.com. So hope I haven't been talking too fast. Happy to entertain questions. Yeah, thank you.